Welcome to another tutorial. Today we are going to make simple flip tank simulation which you have seen in my previous upload, which is shark in a tank. So we are going to make that scene. That is a very simple scene and we are going to make that simulation and render out that you have looked. So for this, but let's get started. For this I'm using this Houdini 18.0.460. So if you have new or older version it will work fine. Just maybe names of the node may be changed. Otherwise it's a simple process and you can get this look. Okay, let's get started. So first we need a geometry, or in my case it is sharp. Okay. So I have uploaded this alembic in my channel or in my site, which is usevfx.com. You can download it from there, or if you don't have, you can just search for a shark animation. You will find lots of animations. So let's locate this file. The file, so you can see it's very large, so we can transform it down. Trans- This is the shark and its loop. You can see that it's a quite long animation. So if you see it just jump, you can increase it to 300. Up to you. 250. Okay, so transform it. So value is 1.2. This is like previous value which I used in my tutorial. You can either change these values. You can make it large, small, anything you want for this. So let's get started. So let me just use a null object. Okay, so this is like simple geometry, and let me just say this so that file crashes we get this. Always save your file. Okay, so this shark is moving and it's going to this. And if you look in the geometry sheet, you can see these values like position values, these are some point number and all that. You can't get all the data here. If you want to extract the data, you have to unpack this alembic. So if I unpack this, okay, now you get all the points data. These are the all UV map data, UV map. If you have map or textured it, you will get this and all this. We're not interested in any of that. You may be interested in this UV map, not any other of this. So I'm not going to use it. If you have other data, you can use here. Just unpack it, it will extract all the data. What we are interested in, the velocity. So if this shark is moving and we are not getting any velocity, so for that, let me just unpack. And to calculate velocities, we are going to use trail node. Trail. Okay. So this trail node is for calculating velocities. So just change it from result type to compute velocity. Now you get velocities. Okay, this is changing. Okay, this is our velocity field. Now we need to make some nodes for our simulation. So we need two nodes, which is collision node. One is for geometry, one is for volume, so that our shark can interact with flip simulation. So it's a simple node. We can go from here. Now we can use collision node. This one, it automatically outputs two output. One is mesh output, one is volume output with both. So just put here in L this sharp mesh, and this is sharp VDB. If you want to look at this sharp video, select here. Okay, now you can see this is the collision. This is not quite accurate. It's losing lot of data. So what we can do here, we can decrease this volume pixel. So let me go for 0.1. Now you can see it is in well interior. If it's closed, just do this. And you can see some like spacing on that. So in order to get proper, you can use this VDB with the shape STF. Use this, it will like expand this by offset value. See, you can expand this, you can if you want to decrease, you can erode. It will like, so we are going to dilate this by almost 2. Doesn't matter, it just interacts properly. Sometimes it doesn't, so you can increase it a little more. And we are done here. So just output it from this node. We are going to use this in our simulation network. Yeah, so we have made this control S so that it can save, and always start from 0 frame. Otherwise, if you put any of other values, it will behave not properly. So let me just make a flip tank. So for flip tank, we are going to use this particle flow flip tank, or you can search here for flip tank particles. See, make anywhere else, doesn't matter. Okay. So we have made this tank. So let's just center out this 0, 0, 1 is 0. So my shark, if I look on top view, let me just disable this so that it can't help it. See, my shark is almost here. This is almost more than 5. This is almost 6. It's circling around. So 6 and 6, 12. So it's almost around 12 radius. So let me just go for 15. We'll cover all my this. And if you want to make bigger tank, you can make bigger tank. And if you go to perspective, and you can see we have quite deep tank, so we don't need that deep because our shark is not going up and down. And this is it almost. And come to this see, if you look here, our shark is moving a bit up. It should be half submerged or partially submerged or completely. It's depending on how you want to look. In my case, I want to look my shark to be partially immersed. So let me just go to shark and just let me transform a little bit. Almost point is more than enough. We have made this flip tank. This is initial. This is interior. We don't need that. We need this one. So and this is our flip tank simulation. So open this. You get these basic nodes, and for simulation purpose and for this tutorial purpose, I'm going to not decrease this value too low. Otherwise, it will take much more time. So let's get started with 0.05. 0.05 is good start. If you have very big simulation, you start at 0.1 or 0.2. Otherwise, it will take much more time to simulate, and it's quite time taking process. Okay, so flip tank, we have this, and not going to change any of this. For it is good. Come to flip solver. In my case, I use these steps 10 by 10. It will interact properly and show more details in flip simulations. So in for simulation purpose, I'm going to use 4 and just go for 2. Other things are as it is, and we don't need this. We don't need. Come to this solver, and if you have like powerful graphic card, you can use OpenCL. So for this, I'm going to use this. Otherwise, if you have good graphic card, you can use this. Otherwise, leave unchecked. Sometime if we ran out graphics memory, it will give an error. And we need some other values, and this narrow band, which is this thickness of this fluid. So we are going to decrease very much low, almost 1. So we want just simulate on this surface. And one more thing we need this is vorticity. We are going to use this in our rendering purpose to make foam or white on the water surface. And everything is good. If you this simulate this, it will not interact with our shark. You can see this. You can see this. It's not interacting with our shark because we need to call here. So to call here, just increase this value to 0.1. When we will simulate, we will decrease this. For the shark to come here, just use this static object, and we need static solver, and we need to merge this and merge this. And order is important. Static object should become first. This is first, second. So just click this. Now it's first, it's second. So it will operate from left to right, like first this, then this. And in static object, you go to SOP path. SOP is shark path. Select this. Go to shark and use this shark mesh because we have calculated this. And for our volume, just change this mode to volume sample, division method to by size, and our proxy volume, which is we have calculated, so which is sharp VDB. Okay. And if you want to look how sharp is looking, you can open this. See, looking like this. Off. And in bullet, if you show guide geometry, this will look like this. So convert this to concave, it will look like this. Okay, now we need to make one more thing, which is deforming geometry, because our shark is moving. So click on this. We get moving shark, and one more thing is important. This value division size should be equal to our this collision division. So this is our 0.01. So we are going to use 0.01 there. We can link all these values, not right now. Okay, 0.01. Okay, now we have connected all the values. Now we can simulate. Just need to simulate. And you can see that it's interacting, but not like what we have wanted to see. It's moving, but there is very less particles, so it's not showing anything. Okay. Moving, it's if you zoom out, you can see why. Okay. Now just let me just lower this value. Okay. Now if we simulate, then we can see these values. Okay, I simulated 20 frames, so you can see now it's interacting. It's interacting. Now this is like pretty much setup code. Now we can do is in my output video I have some rocks around this, so you can create these rocks. It's very simple, not too complicated. We just save this control S and to make these rocks, just make another geometry node, or you have geometry, you can just import it. Okay, so for this I used this tube node. I think I have used this. Height is 0. Okay, this 0, this one, and this like this. Something like this. It doesn't matter which is. So we can like increase this our like size. So we are 15 or 13. It's too big. Well, okay, let me go for 10 or maybe or some lower values. 9, well, maybe 30. Doesn't matter. Okay, now we need to just do some scatter. Okay, and we don't need thousand of these. We just need less rocks. You can randomize this by changing this model, just seed value. Okay, now we need some rock. So basically, rock I made using this pair. Just use this polygon and, and just use 5 is enough. Use mountain and yeah. And if you want to use much more, then use subdivide your network. Use various different methods, whichever you like. And paste. And if you want more detail, just use one more time more mountain. Keep in mind that it will take time to render. See? Or if you want to change this to different, so you can change in to other values. You can use alligator, see, Manhattan, whichever you want. Butling, side. And use sparse also. This one is also good. Or you can just adjust these values, size and still if you look feel like this is less detail, just add one more time subdivide. But I'm not going to use that. This is good for my purpose. Just use null and just add one more normal. Now we need to copy this on our scatter point. So just use copy to points node. Copy to points. Either use this one or use this one. These both are can work. So I'm going to use this. First, we need this which primitive you want to copy. I want to copy this one from here. So just here. Okay. Now you can see I have like this, but you can see all these are in same directions. So we need to randomize this. To randomize this, we can use couple of values. First, we are going to use attribute. You can use noise or random. So just noise. Okay. And we want to randomize its scaling. These are of same size. Just use attribute. Which attribute you want to randomize? So just scale. Scale is for this. Line small, big. You want to like remap these values. How big, small. So smallest can be 0.8, and if you want bigger to be like 2 or maybe 1.5. Now they are like bigger and smaller, and you can again change this different settings. For this I'm going to use the same. Next thing we want to use this random rotate. So let me choose uh, noise, and we want to like randomly rotate this. So to rotate this, we are going to use orient, orient. And if you put this value, see these are not rotated anywhere else because orient is quaternion, which is have include 4 values. By default, it produces single value with this element size 1 means 1 values. We want this to be 4 values, so just put it here 4. When you put it here 4, now it can like reorient, or you can. And one more thing we need to do is this one, use this one. This- use this. Sorry, I'm using wrong. In this case, we are going to use random. I'm using wrong values. So now here you use orient, and dimension is 4. Okay, now we can see it. And you put this one. Its spelling is wrong. ENT. And if you don't know which value we are going to use, so if we come here, you can check which values you want to use. Here. In here, it actually have these values. st- Now you can see these are all reoriented. And if you want less these rocks, use this scatter node and just lower this value. You can get these rocks. But like more close or far, you can use this. It's up to you however you want. Just okay, now last thing is like again we need to create these all collision node and all that. So just please again so let's use collision outdraw outdraw the and if you look here so this is good with okay we are not going to use much more detail here okay we can see that our water is not covering all this so we can always increase this values so put to this here and let me for 20 values that will cover almost every part. Now let's go for here and just we need to add more static object. Just use merge node and again use static object. Means path is raw out of collision volume size proxy volume which is one concave. Okay, everything is set up. What we can do is we can just one more can always increase this size and completely cover just use 25. Be careful with these values, it will take much more time to simulate. Okay, just control S and let me simulate this. Okay, I have simulated some frames. So now you can see these are moving. And if you want some movement in this water, you can always use here some velocities, either use particle velocities or volume velocities, or you can input from outer. So if you want to use particle velocity, use these pop modes, pop modes like here, pop wind. You can use pop noise, force. You can use any of these. It can work. It always pop velocity. These can work. And if you want to use volume velocities, use volume You have to come from here and use source, volume source. The next we are going to make white water. White water is basically simple. You don't of come here. This is white water. Select this and select this here, which is your flip tank, and then press enter. It will basically create your white water. So by default, it works just fine. If you want to like more control it, you can go to this white water source and then control from where which you want to emit these foam. So for this purpose, I'm using these static objects. Just copy these nodes, copy and paste in this. Merge again, order is important. And next, what we want is um, this and come to this white water source, and this is your white water source. You can do from where you want to emit, like from curvature, acceleration, velocity, vorticity, all these numbers. So if you want like accurate values from where, how, which values you want to put, you need to go through this. It will show you the when we simulate this, these values will calculate it and it will show you, and you can now put that in there. So let me just simulate a couple of frames again. Okay, now you can see this that there are some foam is forming here and some is forming here, but not in our shark. See, shark is completely formless. So what we can do here is we can lower these values in white water source. And if you come here, like 12 or something, this frame, okay, and you select put display on this and open this visualization, just check this on. Will show you from where the foam is empty. You can like increase this and we can see there is like couple of here green points. See, some are here, some are there. See some here, but not in this. So the reason maybe these values are very high. So because our shark is not moving too fast, so we can always lower these values. Let me just go for 3. We now have increased these values. We are using vorticity. Vorticity, I know this is not going to be very high. Let's lower this. Curvature range can always lower this. Just don't go inside that. And next is 0.01. Size is still not coming to this. It's I'm basically lowering everything. Maybe couple of values here and this. visualization of big and compare white water and white water source. Remember these values, and you can decrease this value also. This will also increase the emission. It will pick small details. So just go from point to not going very low. Be one. Be careful with these values. From here, just go to zero. We don't want bubbles spray. We just want only foam, and everything is fine. Okay, now we can simulate too. Now we can see there are some points are there. We are going to lower this further down. Now just see. Okay, the foam is still not coming on our shark. Maybe the values for fluid is too low. Just disconnect this and come here and just go for 0.03. This is will be quite high values. And now come here. Now we can see if foam is coming. Okay, now we can see that now it's producing some foams. So it's just values are too low. So in order to get these working properly, we need to simulate this on some higher values, 0.02 or 0.01. And if you want more detail, just come here or just increase this substep. Be careful with this, it will take more time because my simulation took around 8 to 9 hours just for this flip simulation, and again for 3 to 4 hours for this white foam simulation. So be careful with these values. So if your system doesn't support it, so don't go that high. Do it as maximize as goes. So let me just call my caches here, and these values, I just disable this. So if you come here, this flip feed, this is basically where the cache is. This is calling all the caches. So you just call here the my cache because if you are going to simulate for high values, it will take much more time. This is our tank simulation. My simulations are almost 56 GB. So just call this a couple of times. So these values. This is my simulations. This is my, and we want only to show particles. Okay, it is my particle, and if I put go around some 60 or some further frames, it, now you can see that I have this shark is moving, and these are rocks and other things. And if you want to like, we are visualizing this velocity, we can visualize vorticity. See, this is vorticity for our shark velocity. And if you want to look how much is your velocity and all that, just as a good come to geometry spreadsheet, and it will show you all your like velocity and vorticity. Mine is too high. Or um, so come to here this particle fluid surface. It will basically convert this fluid to mesh. So um, this is our mesh. It's quite high density mesh. Having some, this quite high density mesh. And next we are going to use this. We are not going to, and for foam purpose, you come to this wide import. Always come to the first frame, and we are going to load here. This node, load from this. This one foam. This is also like 47, 48 GB. Yes, we come to this is simulated for 250 frames. So come here. Okay, now this is our foam, and it is also quite high density. The foam count is 5.2 million. So it's quite high. 5.2 million particles. Okay, so we have like foam and all this, and obviously these will not match because I made this here, and in my original file these are of different shapes. So what can I do is I can call these so that it call matches. Copy those nodes from there to here so that it all matches. Then we can do our rendering process. So simulation will always take times. You can always optimize this. You can see here we have exactly same thing. To copy this, I'm going to use shark node and our rock node. Table this and download this and rock. Okay, so this will be our rock and all this. It's giving error. Don't worry. We It's because it's disabled. That's why it's giving error, and we don't need anything else. Let's close this. So uh, just move one or couple of frames. It will update this frame. Okay, now you can see it has updated all those frames. So now we can do rendering process. So for this, let me just make some render nodes. So we are going to use V-Ray. If you have Octane, you can use this also. Octane is quite fast. V-Ray is also fast, but not that fast. Octane is quite fast. If you don't have both these, you can always use your mantra. This is also good, but it will take much more time. So be careful with this. Water and all this they take very long time to render. Or if you are some new, you can always go to this Solversys staging app. You can render from there also. It's quite fast, but not that fast. So I'm going to use render. So I just use render. Can use any of this and always save your file because when we render it, try to do a lot of things. And we need one camera, so let's just use new camera. And for this, just okay. And I'm going to lower this resolution so that it will render much more fast. Okay. Yes. And for this, we need light. For light, we need V-Ray. So it's dome light, and you can use any light color, or if you want to use texture, you can use STRI texture. So if I go to I think I have used this Photoshop. You can use daytime, nighttime, anytime of. Yeah, I use this Photoshop one. I have downloaded this from polyheaven.com. You can download it's free. You can download it. And if we try to render this, just uh, uh, the shark. Okay, we don't have material yet. So if I render this, it will look like this. So what we can do, we need first water So this is our water. So go to this material section. These are your default shaders when we are using with Mantra. You don't need to add material. Houdini automatically add these shaders. Just add lights and render it. It will you will look your render will be fine. So for our V-Ray, we need to make shaders. So come to V-Ray material. So it will be our water material. In water material, just go to this settings and get this water. And if you want to make this, you can make it. It's not that complicated. So we have made these waters. Top is just refresh it. The object, and this is a fluid tank, and this material water. I will have this pure water material, and next we need our rock and all this material. Just use same technique and you will get all this already. This for rock. I use textures, so not the same. Rock, let me just put a simple brown color. Rock, where dark, so you can know this is your. This water is looking like green or something. Yes, we can increase its intensity, light intensity, be a little more brighter. Next is we need some. If you want like water to be transparent, uh, go to this shader, water shader, this one. So here you can see we have like fog color. If I zero this, it's like completely transparent. It's up to you how you want to look your water, and because it's transparent, there is nothing between below this surface. There is nothing. So just use a grid or any simple plane. So for this, let me just go for grid to put this below our like fluid surface. Not too much, just to cover this. Now you can see the look is changed, and we need some color. Either you can use some sand or dark rock texture. Let me just use this simple rock. Now you can see, and again for our water part, now we can lower this value 1 1, just very low value, 0 0 1, maybe 0, something like this. And foam is almost looking good. and we don't need anything else. If we want, we can use foam, some material also. White value here, 195 will be good. White button this one, and just use 0.95 is I think very right. It's right. You can always adjust its values how you want to do. This is like basic foam. If we like disable this foam, this is our this one. Nice. Okay. Now if we like render, you can see there is this water is moved, but it's not white like you have seen in the ocean or in water. When something is moved, the water becomes white behind that. So we can do that. It's a simple process. Just come here in the fluid tank here. Yes. What we can do here, use warp network. Active warp, use any warp, it doesn't matter. Shaded, light off. um, and what we need is we need these values, these what velocity and vorticity, which we have calculated. Like vorticity is going up to 105 to 0 to 105, and velocity is going from 13 to negative 5, I think. Okay. So you can coincide. So we have this velocity. So you can use length node, okay, length node, and if I put this in velocity, it will calculate its magnitude. See, now it's 10 below and positive. Every value is means it will only give you positive values. Okay. If we don't use like directly, if let me just put this in color, you can see color can go negative or positive. You can use ramp also to match these values, but we are going to use length. Color is okay. Okay, now we need like our vorticity, this one, so we can use this bind. We need to name this attribute. This is vorticity, vorticity, and we need to bind code to we can name any form, whatever you want. Just connect this, so it will be like this form, this value. This is this same, and we can put the range values. So we know that vorticity maximum goes to 47. We can put like maximum is 50. So our foam value will be from 0 to maximum 1. Okay, we can now add these two values. So just use add. We can multiply this. We can use multiply. We can multiply this, and its product goes to this. Okay, that's going from 3 to 12. And last, we can use another range, and we know that its value going from this bypass this. Ohm is maximum going up to 12 to 3. Okay, so we can use like 12 values go. So it will be like maximum 0 to 1. Okay. Now we are going to use this value to our shader. If we go to put this color, you can see here also. We not here. Oh, you can just. We will see this in our shading network. So remember the name of that attribute, which is foam. Foam. Go to this water shader, and we need to put that value in emission attribute. So emission attribute. Just use user float and name is FOEM. Here, see here, and this is- maybe it will become very bright. We need to lower it down. This the user. Sometimes doesn't show. Just do one more thing. Sometime it uses user code color. You just use home. We can see one more thing to do. Go to this right here. Just connect this value to color. Pass this value. Okay. So this fit value is like clamping all the values. Let me just give 5. Don't bypass it. You see. So we are getting this white water kind of. If I lower this value, 5, yeah, maybe that We don't need that. Now you can see it's coming. It's white. If I turn on our home also, it has this. If you want long white water like this, just you can lower the values which are present here. You can adjust these values. I have used this like vorticity. If I bypass this one, you can see it will be like around here. It will around everywhere. So we don't need that strong. That's why we are using some bit ranges. Or if you are not using here, you can use directly here. It will lower these values, but not too much. And if it comes too bright, you can always dial it down from shader from here also. It's up to you how you want to. So just we have already set up everything. So the only thing remaining is like tester these and just add camera and render it out. So to render this sequence, you need to just come here in images section, like write this, save, and just give some address, whichever wherever you want to save. Name this anyone. Home dot dollar $f dot exr or jpg png whatever you want. Say accept and just make this to frame range and render to disk. It will render out your whole sequence. I think this is the exact process which I've used. So its tutorial may be a little bit longer, but I hope I have covered everything which I have done in this tutorial. So kindly make something like this, and if you make something good like this, just tag me and show me, or you can just upload it. Okay, so thanks for watching. We will see you next time. Goodbye.